Hey guys, this is Taylor here and today we'll be solving the problem count island with total value divisible by k. And this is 3619 problem which is from weekly contest 161. So let's get started. So what we have given we'll quickly see. So we have given an m cross n matrix grid and a positive integer k. An island is a group of positive integer representing land that are directionally connected, okay, horizontally or vertically. The total value of an island is the sum of the values of all cells in the island, okay. Now we have to return the number of island with a total value divisible by k. Okay, so let's see what is given to us and what we have to do. So basically we have given an m cross n matrix. In that m cross n matrix there are two things. Either that will be a land or it will not be a land. And how we distinguish? So if that value is 0, that means that is not a land. And if value is greater than 0, then that means it is a land. Okay, I hope that is clear. So this is definition of land and water, and I mean not land. Okay, now what we have to do, we have to find island. So what is island? So if we try to connect, so we have given something like this. If we visualize this, so this is an island. How this is an island? Because it is connected horizontally, it is connected vertically. So this will become an island. If we try to find out other islands in the graph, so this will be island because these are horizontally and vertically connected. How? So this is connected vertically, horizontally, horizontally, and vertically. I think this is also an island because this is an island with a single land, and this is also island with a single land. Now, what we have to find? We have to find among all these islands, whatever the value present here, we have to sum up. So land is a group of positive integers. So we have some integers given here in the land. We have to determine what is the sum of it, and if check if that sum is divisible by 5, or I mean 5 for this test case, and if that sum is divisible by k, then we have to increment our counter, and in last we have to just return this count, how many number of islands are divisible by k. So I hope the problem is clear to you. Let's try to solve it. Um so how we will be solving it? So this is a typical graph problem. So if you don't know graph problems or you have not solved this kind of graph problems, so what we do in these problems are uh, each of the cells we visualize as a node in a graph. Okay. So our graph node can something look like this. So my graph contains zeroth node, then first node, second node. Okay. So this is like this only. But the only thing is instead of this number we have index. So if I have to visualize this as a graph, so I will put something like 0 comma 0, and I will put as it is a node. If I have to put like this, so I will type 0 comma 1, I will put it in a node, and this will be my graph. Okay, if we type this, so 0 comma 2, and this will be my another graph, and this is connected. So we have to visualize like this, and then it will be very easy for us to solve the problem. So let's see how we will be solving it. Let's try to dry run this and see how we will be solving it. So problem simple. We have to just go to all of the connected components and we have to find their sum. And in the end of the day, we have to check that sum is divisible by k or not. Accordingly, we will increment our counter. So how I will be solving this problem? Let's see. So I what I can do? I can start the graph traversal. So in normal graphs, what we do, we create something like adjacency matrix or adjacency list, right? So here we have given already this grid. So we don't have to do anything. We will just start iteration from here. And you also know one thing that in graph problems, we try to create a visited matrix, right? So let me create visited matrix. So I have created the visited matrix. So this is my visited matrix. So what we'll be doing is we will be starting our iteration from here, from this node. And how we'll be iterating? We'll be going from this node, then this node, then this node. So like this, like this, like this, the matrix traversal, okay? And we'll consider each node as a graph, each node as a graph node. Okay, so let's start. So this node is 0. So do I need to do anything? No, I don't need to. I will go here. This node is land, right? Okay, so here there are potential chances that this can find some island which can be divisible by k. So let's try to flip. So first of all, very first thing, if I found this as a land, so what I will be doing, I will be marking this as visited, this as visited. Okay. Now I will take this 0, comma 1 here, and I will try to find out what are the four directionally connected components I'm having. So because we have given that land can be represented as four directionally connected horizontally or vertically. So I have to move this side, this side, this side, and this side. Let's do it. So I will be moving this side. I will be checking whether this is 1, I mean whether this is greater than 0. Yes, it is greater than 0. So I will be going, okay, yes, 0 comma 2 is also a connected component, is also a land. So this can be my island, part of island. Now I'll be going in downside. This is, yes, this is also. Okay. So I will be writing, it will be 1 comma 1, I think. Yes. Okay. I will be going left. So this is 0, right? So this can't be a part of it. So I will not, so this will not be possible. And if I go upside, so this is definitely not possible because it is out of bound. Okay. Now for this thing, I have to do same thing. So what I will be doing, I will be checking right side. This is greater than 0. No. I will be going downside. This is greater than 0. No. I'll be going left side. So left side is also visited, already visited, right? I won't be doing this. And also one more thing. So as soon as I reach any node, now I will mark it as visited. I will mark it as visited. This is, I don't need to do. So I will mark this for this X. I have to mark this as visited. For this X, I have to mark this as visited. Now this is already visited. So I don't need to do anything. Now I will try to go upside and this is out of bound. Okay. Now I have a second this node, so I will try to explore all the four nodes. So I will try to go this side. Okay, this is already visited, so I don't need to do anything. Now I will try to go downside. Okay, so I will check downside. So downside is already is 0, so I can't do anything. I will mark it as visited. I will go to left side, and this is also 0, right? So I will mark it as X here, and I will market as visited. Okay, I hope this makes sense how we are doing this. So we are just doing a small dry run just to make sure that we don't make any mistake and we understand properly. So okay, so I was here. I was traversing from here, right? My node was here, and inside that traversal I moved here. So we can do two things. We can either use DFS or BFS, both whatever we can use, so both will be taking the same amount of space. So we will be working on the DFS solution. Okay, so we visited this node, and after visiting, we found a land. So we tried in depth, we went in depth until we found all the lands. So we found this three lands. So we visited all these lands. So this one all explored. Okay, because we are working in DFS. Superb. So now we'll be going here in this case, and we'll be checking whether this node is visited or not. So I can see this is visited, so I will move next. I can see this is also visited, so I will move next. Okay. Now this is not visited. So what I need to do, I need to visit it first of all. Okay, I will visit it. I'll check whether this node is 0 or land. So yeah, it is 0. So I can't do anything, nothing to do. Okay. I will try to move here. So this is already visited. This one not visited. Okay, let me visit it. Now this 0 is not greater than 0. So I will don't have to do anything. Now I went here. Now okay, I will visit it. Now is this a land? Is this is a land? Yes, I can say this is a land. So I will be 0, say I think it will be 1 comma 4. 0 1 2 3 4. Okay. Now I will try to explore all four directions. So I will go here. This is out of bound. Okay. I will go down here. This is, I can mark this as visited, and this is 0. So I don't have to do anything. I will try to go left side. This is also 0. I'll mark it as visited. Okay. Okay, this is already visited, so nothing to do. I will try to go top side. This is already visited. I don't have to do anything. Okay, so so far our visited array looks like this. Okay, now I will try to go again. I will start from here. Okay, one more thing. So what we have to do, we don't just have to keep calculating the visited array and all. We have to keep counting. So as soon as I have told that okay, this is I got one island, I have to calculate the sum of it. How will be doing it? So that is also very easy. So once I have visited all the indexes, all the nodes in the DFS, after completing DFS, we will be calculating the sum. So in DFS, we keep calculating, keep adding the numbers, keep adding the lands. And as soon as our sum is ready, we will just check the divisibility. So 5 to 6, 7. So 7 modulo 5 is not equal to 0. So I won't be adding any increment here. So K is 5 here. Okay, so this is 5. This is 5, and island sum is also 5. So I will be definitely incrementing my count. So my counter will be it was 0, but as soon as it reached here, it will become 1. Okay, super. So let's try to visit other nodes. So I visit this node. This is not visited. I will visit it. This is 0. This is already visited. This is 1. I will visit it. 1. Okay. So now what I have to do? So I have visited it. Let's write it here. So it will be 0, 1, 2. Let's try to visualize the here itself. I think that will be very easy. I will visit here. Okay. Now what I need to do next? I need to explore this part. Okay. So this is 0. I don't have to do anything. I will try to explore downside. Okay. I got some land. Yes. So first of all, I will visit this. I will visit this. Now I visit this. So I will put that in a recursion. So DFS works like this, right? So I will put this node in a recursion. Let's like this. Now I will try to like so DFS will work on this node first. So I will go here. I will try to go in depth. So I will go here. This is visited. I again got the land. So I will put it like this. Okay. Now I have visited this one as well. I will try to explore this index, all the 4 indices. I will try to visit this. This is visited. This is 0. I don't have to do anything. Now I will try to go downside. This is visited. Okay. Left side is also visited. No issue. Upside is also visited. Super. So I can pop this node. So we don't have to maintain anything. This will be taken care by recursion. But in case if you have to don't want to use recursion and you have to declare your own stack like BFS we used Q, so you can do it like this. So where were we? I think here. Yes. So 7 we explored and we got nothing. So we will try to go this side. We will try to visit this. We got nothing. Okay. We'll try to go left side. We'll visit this. We got 1. Okay. Let me add 1 here. Now, this 1, I will try to visit the right side. This is already visited. I try to go downside. Let me visit it. Let me add it. Now I will try to go right side. This is 0. Already visited. No issue. This is out of bound. This is already 0. I will visit it. Upside is already visited. No issue. Let me pop it. Now I am here. I was exploring the downside. So I will go left side. So let me visit this. Now I will go upside. Upside is already visited, so nothing to do. Okay, 1 is also done. Let me pop it. So I'm on 4 now. Now I've explored the right, down, left. 1. Let me explore. Try to explore 1. 1 is already visited. Nothing to do. So I can pop this 4 as well. So in this time, I was calculating the island sum as well. 1 plus 4 plus then 7, then 1, then 2. So what is the sum? 7, 8, 9, 10, 11, or 4, 15. So 15 is divisible by 5, right? So I will increment my counter as 2. So, okay, I think I was here and my DFS, like my matrix iteration was here. I will try to go next, visited, 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 visited. Okay, this one is not visited. Let me visit it. Okay, let's visit it. So I will try to visit this. Okay. I will go right side, nothing. Left, downside, nothing. Left side, already visited. Upside, already visited. So I got my island sum as 8. Is 8 modulo 5 equal to 0? No, it is not. It is not. So I think we got counter as 2. Let's check whether this is correct or not. Okay, I think it is correct. So I think you guys got the idea how we'll be solving this problem. And if you have any doubt, just feel free to comment down. I will solve it. So this is how we will basically solve this problem. This is simple graph problem, and let's try to write pseudocode of it now. So the first thing that I have to do, very simple thing, I have to iterate over all of the over all of the nodes of matrix. So that thing is very simple. Matrix traversal is very simple. So for I from 0 to row minus 1, okay, whatever my row count is, I will go from minus 1, and for it should be I, okay, and for j from 0 to column minus 1, what I need to do, I need to first check whether this node is visited or not. Okay, if not visited, I of I and j, then I need to DFS of it. I need to go to DFS of it, I comma j. And how I will be writing my DFS function, let's see. DFS will be taking I and j, and definitely it will be having access of visited array and all. Okay, so what I need to do? So what we were doing in DFS, we were exploring the 4 direction. But before that, what we were doing, we were just checking whether that node is visited or not. Okay, so I will check that condition first. So if I comma j is visited, then I can definitely return a 0. So this is not giving me any island. This is not giving me any island. This is not land. I can directly return 0. Otherwise, what I need to do? I need to explore 4 directions, right? So to explore 4 directions, there is one trick that I want to teach you. So if you are, let's say, some node x comma y, okay. If you carefully visualize it here, say you are basically in middle of here, in, let's say, you are on this node, let's say. What is your x? X is, let's say, 2, and y is also 2, 2 comma 2. If you try to go right side, what will be the index? The index will be 3 comma 2. Sorry. It should be, row will be, say, 2 comma 3. Okay. If you go downside, it will be 3 comma 2. If you go left side, what will be the index? The index will be 2 comma 1. And on the upside, the index will be 1 comma 2. So can you determine some formula out of this? Yes, we can determine. So the right side, I am just incrementing the column, and the left side, I am just decreasing the column. Yes, in the top side, I will just decreasing the row. Okay, in the bottom side, I am just increasing the row, and the y will remain same. So I think we will be using this formula. So what I can write? Can I write something like this? So if I have some value like x comma y, so can I write something like this? So if I have to visit this one, what I can do? I can keep the x same. So I will making it as a 0. Okay, and I need to do plus 1 here. Okay, for this part, what I need to do? I need to do plus 1 here, and y will be 0. For this part, what I need to do? I need to basically keep it 0, and here I need to place a minus 1. And for this, what I need to do? You do minus 1 here and 0. So I will be using this thing. This part will help me explore all the 4 directions, and my task will be very easy then. So let's see what we have to do. So I am typing something like this: for x comma y in this 0 comma 1, I will be iterating. So you can definitely write 2 loops, and 0 1 0 minus 1. you can do x from here, then y from here, 1 comma 0 comma minus 1 comma 0. So in C++ or Java, you have to do like this, right? So this will map to this is something like this. But in Python, we can directly group these things. So we don't have to do anything like that. And our task is very easy. So in Python, what we can do, we can have a two iterator over list. So I will write something. So don't worry if you write code in C++ or Java. I'll make sure I will put a code in the description. You can check it out and definitely it will help you. So 0 comma minus 1 and minus 1 comma 0. Super. So what I need to do? I need to found the row. So what is my current row? So row will be x plus whatever I am having. So this x means this plus whatever I am having. My new column. So let's make it q and new row, new column. New column will be y plus j, whatever j I'm having. So that way I can basically explore all the four directions. Now I need to do one thing. What I need to do? I need to check for the edge cases, basically whether this node is going out of bound or not. So for that, I will try to quickly write one function, check out of bound. Inside that function I comma j, I have to check whether my I is less than equal to 0 and I is sorry, I wrote what was it? I is greater than equal to 0 and I should be less than my matrix row length, and j would be greater than equal to 0 and j should be less than matrix column length. So why we are not writing equal to? Because we are working on indices. Superb. So I will call this function to check whether that is valid new row and valid new column or not. So if check out of bound of new row comma new column, let's try to put this part little below. Okay. If this is case, so what I need to do, I need to go to DFS, right? I need to go to traversal. I need to traverse this. Okay. And in meanwhile what I will be doing, I will be marking this, keeping one answer here, answer equal to 0 and answer equal to answer plus whatever DFS I'm getting from this. So I'll pass new row comma new column. Super. And after all the summation, we will just return the answer. So what we are doing here, let me explain you. So this is, if you know recursion very well, it will be very easy for you. So let's say I'm here. Okay. Now I just call DFS for this part. So I am considering that I will explore this four direction for this node. Okay, for this node I will be exploring this four direction, and whatever island is going here, whatever island is basically present four direction to this node, this will return me. Okay, this one will return me. Let me write something beautiful here so that we can visualize. So let's say I'm on X on Y. This is my right node, this is my up node, this is my down node, and this is my left node. Okay. Now what is happening? So I will be calling four directions for this node, and my recursion will take care to get answer from this to here. So whatever islands I am having here and inside this, in whatever depth it is, I will make sure that this will return me this answer. So that's what I am doing here. I'll just focus on calculating this part, only this part, basically for one node, and rest all will be taken care by DFS. So I mean depth first search, recursion. So if you have any doubts in this part, just let me know. So what I need to return here? I need to return answer plus my current grade of I comma j. Why? Because I'm what I'm doing here. What I'm doing here. So I'm this will get me answer from this side. This will get me answer from this side, this side, this side. But I'm not writing this answer, right? So I have to add this answer as well. So that's why I'm writing here grid I comma j. Super. So this is basically returning me all the islands sum. Okay. So I am having island sum here. Island sum here. I need to just check two things. If island sum not equal to 0 and island sum modulo k equal to 0. So this condition is important because 0 modulo k will definitely be 0, but that is not valid answer. So in that case, I need to increment my counter plus equal to 1. I can write my counter 0 here, and in the end of the day, I just need to return the counter. So I hope this is clear to you guys how we are doing it. Let's try to code it. So it is highly recommend to just first try to code it yourself. I think the approach is pretty clear to you, and we have written the pseudocode here as well. So I think this much information is enough for you. If you are facing an issue, then let's code with me, and we will check how we can resolve this. So let's try to code it. So I have to basically I will just try to see what functions I have to write. DFS function, a check out of bound function, and I have to write some main logic here. Okay, let me write it. So I will start from this check out of bound. I will be taking two values I comma j, and what I need to return two things. Whether my 0 is less than equal to I and less than, let me type something like this, row length equal to length of grid, and call length equal to length of grid comma 0. So this two helper variables will definitely help me, and my ongoing task row I can just copy paste it from here, and my j should also lie in this range of call length. Super. So I just need to write. So this is a Boolean expression. If both are true, then it will return true. Super. Now next thing, what I need to implement, I need to implement this DFS code. Let's implement this. So DFS of I comma j. What I need to do first of all, I need to check if visited of I comma j equal to true, then I need to return a 0. Otherwise, I will be visiting it. Super. And what I need to do next, I need to declare one answer variable for x comma y in 0 comma minus 1. What was our range? 1 comma 0, 0 comma 1, 1 comma 0. Okay. 1 comma 0, then we have 0 comma minus 1, then we have minus 1 comma 0. Super. So I need to calculate new row, which will be I plus x. New column will be j plus y. I need to check if check out of bound is returning me true. Check valid. It should, let's rename it check valid index, because that is more correct name for this function. Now my new row and new column, if those two are sufficient, are satisfying this condition, then I can definitely get some answer from this, and I can call DFS for this. So new row from a new column. Super. Now in the end of the day, I need to do two things. I need to return answer plus I need to return whatever value I'm having here and here, whatever the current value, and left value, right value, top value, down value. Okay. So now my task is very simple. I just need to implement this function and I will be done. So I will be defining my counter variable like this for I in range and row length LENGTH. Okay, for J in range, call length, and I will be getting some island sum. Okay, island sum, yes. Island sum equal to DFS of I comma j. So I don't need to check visited condition here because I am already checking here and I am returning 0 as soon as it is visited. So that will be handled from the DFS function itself, and my this code will be very clean. So if island sum equal to 0 or not equal to, it should not be equal to 0. Okay, and island sum modulo k equal to 0. If it is divisible, then I can increment my counter, and in the end of the day I can return my count. So let's try to run this code and see whether it is working fine or not. Okay, my visited array is not defined. Okay, super. So I need to define my visited array, and visited array will be what? Visited array will be same as my this matrix. So in graph we used to maintain visited array, right? So it will be same, and initially all the values will be false. For I in range, call length, LETH, or J in range, row length, LETH. Super. So now my visited array is defined. Now let's try to run this and see whether it is working fine or not. Okay, I'm getting a wrong answer. Why? Yeah. So we did two silly mistakes here. First of all, this should be AND condition because both should satisfy, and then only I will increment my counter here. And the second thing is I can have one more condition here. Grade of ij should be not 0. If it is 0, then I can definitely return a 0 directly, right? So if I write something like this, so it should work fine. Let's try to submit and see whether it is working fine or not. It is working fine, yes. Okay, so I hope you understood this problem, and let me know in comment section if you have any doubts, and please give a thumbs up. That will tell me that you guys are understanding, and if you need any feedback, if you have any feedback or you have to uh, any suggestions to improve the videos, then just let me know. Okay, thank you very much for watching this video.